historic event. So
with a lot of crisp air.
yeah, that's true.
And something, I mean, back in the 18th century, if you think about it, when Edmund Halley came out with his plan, they had, these 2 tries to get these calculations down, and if they didn't, all of the astronomers at that time would be dead. They would have to start, not start all over, but the experts at that time wouldn't be there. So it was really crucial then, and, still crucial now. Very important.
Yep. She's playing to dad. That's okay. It's a family show. We always support families. Camila's dad's a big supporter as well. But that's what we do here at NASA Edge. And if you want to watch more NASA Edge programs, you can visit our website at www.nasa.gov/NASA Edge and download one of our mini vodcasts, and hopefully you can see this kind of programming and others and learn all there is to learn about what NASA's doing in science, engineering, math, and technology, and exploration.
Well, your father just walked out the door, and it looks
taking
like
pictures too.
Flash or say, "No, Lou, it's okay. You can talk to us. Everything."
Cloudy eclipse trip.
Oh,
cloudy eclipse trips.
So Dad's in the back watching coverage of the show, pointing out to his daughter Kara that there were cloudy eclipse trips. So they were like the French astronomer.
I was 8 at the time, and and while I was very interested in the eclipse, I think I was also running around with friends and playing tag. But yes, it was cloudy. Did it rain? I think it rained too.
Nice memory.
Yeah, nothing like nice family moments here on NASA Edge. Well, I'll tell you what, let's go back to our solar coverage, and then in a few minutes we'll be back with more interviews and more question and answers from our viewers as we watch the final moments, or final hours of the Venus transit. It's a lot longer than I actually originally thought. So anyway, you're watching NASA Edge.
An inside and outside look at all things NASA.
Thanks, Franklin. Thanks, girls. Appreciate it. To our audience out there, I just want to give another shout out, words of recognition to the Galaxy Gardens. They're on the Kona side. Elaine has been running things on the Hilo side, but they're on the Kona side, the Galaxy Gardens. And we want to give a shout out to the artist John Lomberg, who's actually was Carl Sagan's illustrator for 25 years. And I believe that he's here watching the transit, watching the footage, and of course he's doing it in the glorious Galaxy Gardens, which is actually, which you saw in one of the video clips we had earlier, and video doesn't do it justice. It's a big garden that's landscaped in such a way to represent our Milky Way. I'm sorry, our galaxy. Maybe I ate a Milky Way when I was at the Galaxy Gardens. I can't remember. But anyway, it's a beautiful floral landscape representation of the galaxy, done very well, and they're down there watching. So thanks, guys. We really appreciate it. Send your comments and questions. We'll be on for another 2 hours. As long as the caffeine and oxygen holds out and Venus continues to move, then we'll be in good shape. You're listening to NASA Edge.
They were the greatest navigators in the world. By interpreting simple things like wave movements, cloud formations, and the arrangement of the stars, these ancient people could find destination points thousands of miles away. And it wasn't guesswork. These were the voyages of the Polynesian wayfinders, the greatest mariners the world has ever seen. 1778. Captain Cook is about to land on an unknown island 2,500 miles from the nearest mainland. He will call this land the Sandwich Islands in honor of John Montagu, the 4th Earl of Sandwich, a supporter of Cook's voyages. Today, we call it Hawaii. But the island is not unknown, nor is it uninhabited. To the people who live there, they call the island Oahe. These ancient people are descended from the Polynesians. They have lived here for over 1,000 years. Not only have they lived here, but they have thrived. Cook is stunned when he meets them. How, he thinks, could these technologically primitive people have come so far across the vast stretches of Earth's largest ocean?
Well, I think their feat is almost unparalleled. You have to realize the time 1,000 years ago when Polynesians were treating the ocean as an open highway, that the Europeans were still just clinging to the shore. I mean, most European sailors couldn't even swim, even back in Captain Cook's day. Captain Cook, I believe, could not swim. So it was a very different attitude towards the sea here in Polynesia. It was seeing the sea as an open highway upon which they could survive almost indefinitely as long as they had enough rainwater for drinking water. And the fact that they could navigate this immense space, I think, is a tribute to what an amazing feat Polynesian navigation is.
So the Polynesian Triangle is really a grouping of islands that share a common language and culture, with Hawaii in the north, Aotearoa or New Zealand in the southwest, and Rapa Nui or Easter Island in the southeast. And all these island groups in between. I really like the term Oceania, coined by, I think, Epeli Hau'ofa, and it gives that sense that the ocean is something that connects us all rather than divides us.
Our people were traveling, great distances, and when I mean great distances, I guess I mean like 2,000 miles or more throughout what we today know of as Polynesia. Way before Columbus, even a couple hundred years before the Vikings were sailing in their part of the world, our people were great navigators and knew that they weren't going to fall off the edge of the earth. They were great observers, greatly intuitive to their environment around them, and weren't afraid to just go out and explore.
So you got to realize Polynesia is the size of North America. So imagine this. Imagine all of North America being flooded, and imagine it people who could steer by the stars from Mexico City to Barrow, Alaska. That's the geography covered by the Polynesians.
How does wayfinding really work?
Wayfinding is a term that's related to navigation and how our people use the celestial bodies, the atmospheric conditions, the oceanic conditions to navigate their way from point A to point B.
It never ceases to amaze me how the ancient Hawaiians were able to interpret various indicators, celestial objects, birds, migratory marine animals, winds, currents, to be able to deterministically navigate their way around the Polynesian Triangle.
In wayfinding, you're using celestial bodies, the stars, the sun, the moon, any planets. And so when you see them rising or setting throughout the night, you have a given direction, and you can base the direction that you're heading relative to that point on the horizon. And that applies for the sun and any other rising or setting celestial body.
In one example, say a trip from Hawaii to Tahiti. As you cross the equator, the Southern Cross is used, along with meridian pairs such as Merzan in Canis Major and Canopus in Carina, the keel of the ship. Using these angles, an imaginary north-south line is cut through the center of the deck. This maintains a course for heading to Tahiti. When the clouds change to a brownish hue, it indicates land, as the underside of the clouds reflect the island color. Migratory birds are also observed to point the way to the island.
Well, it's pretty clear now that the Polynesians did settle the Pacific in purposeful migration, using the stars and other methods to navigate across the vast ocean. There were beliefs, like in the 50s and 60s, that maybe they just kind of stumbled across these different island chains.
The Polynesian Voyaging Society was founded in 1973 to show that ancient Polynesians could have purposefully settled the Polynesian Triangle. They set out to prove that the non-instrumental navigational art of wayfinding really worked. To do this, the PBS built a replica of a double-hulled voyaging canoe, the Hokulea.
This canoe is very strong. I mean, for 36 years she's been sailing. It really gives credit to those who have built her to be really tough and withstand the probably 100,000 miles that she sailed.
Since 1975, the Hokulea has journeyed across the Pacific, recreating the ancient routes of the Pacific Sea trades.
You know, one of the great accomplishments, I think, is finding Easter Island, which, whereas the rest of Polynesia mainly come in chains of islands, Easter Island is just one little dot at the southeastern point of the Polynesian Triangle. And the fact that they could find that is a striking navigational feat.
Just how expansive were these ancient mariners? There is one intriguing story unfolding on the California coastline. On one of the last pristine wilderness areas in California, the Channel Islands, archaeologists are finding evidence of an ancient seafaring culture. Fishing hooks from the coastline of the American continent have similar qualities to ancient fishing hooks found in Polynesia. Considering the talent Polynesians had for navigating, might it have been possible that these navigators reached the Americas? Polynesian artifacts have similarities to those found in South America, and the sweet potato, which is native to South America, has been found on Easter Island. Could it be? If it is, then it might just rewrite one of the most widely held beliefs about the way humans settled the Americas. For a long time, it has been accepted that during the last great ice age, when immense glaciers locked up seawater and lowered the sea levels, ancient peoples walked across the Bering Straits from Russia into the Americas. This would place the New World Exodus about 10,000 years ago. But the ancient seafaring artifacts on California's Channel Islands predate this exodus by an additional 2,000 years. Could it be one more piece of evidence that the Polynesians sailed across the Pacific, even to the American continent? If this is found to be true, then it would imply that the Polynesians developed a technique for regularly voyaging across the vast Pacific Ocean. That accomplishment would show that the Polynesians were, indeed, the world's greatest mariners, with no equal in human history. Only further research and anthropology will someday give us the answer.
The early Polynesians and the Hawaiians, who were basically explorers of their day, they were exploring distant islands in a vast ocean. using nothing more than the instruments, their senses. Today's explorers are astronomers on the top of mountains like the one we're on here. They're explorers because they're discovering new things as well. Their discoveries are distant objects in this vast universe. So in a way, there's many, many parallels that we can draw between yesterday's explorers and today's scientists. I don't see that as discrete moments in time. I think it's more or less a continuum of man seeking knowledge, of getting a better idea of his place within the cosmos.
Hey, welcome back to NASA Edge. Again, we're bringing you live coverage of the Venus Transit on top of Mauna Kea, outside the NASA IRTF, or the Infrared Telescope Facility. And we have Alex and Holly back with us to answer more of your questions. You guys have been delivering some great questions today. We thank you so much. And unfortunately, we can't answer every single question. But that's okay, because a lot of those questions you've been turning in, we'll try to answer those on venustransit.nasa.gov. Right? And before we actually get to the questions, I do have a shout out to a school in Melbourne, Australia, a school of 55 students. It's Hoddles Creek Primary Elementary School. So shout out, thanks for watching us today. Glad you're enjoying the coverage. You guys ready?
Yes.
How you guys feeling, by the way? 14,000 feet, long day?
Good. I have to admit my brain's not quite as clear as it has been before.
Okay.
So, but I still feel pretty good, though.
So would you say that you're probably at Blair's level now, or are you still...
No comment.
Okay, but before we get started, we have to talk about the hat. So where are you at on the hat?
Well, we've passed the halfway mark. As we can see, the dot is getting close to third and fourth contact.
You have about an hour and a half until third.
Yeah, so it's going to move a little more, and then eventually it's going to go away.
And we're done.
Yeah. We'll be done.
21:17.
Exactly.
Yeah. Okay, so let's get to your viewer questions, and let's go to question number one. Does the sun look much larger from Venus than we see from Earth?
Well, yes, because Venus is a lot closer. So the sun is brighter, there's more energy that's reaching it, and it's a lot bigger.
You can imagine it would be pretty cool to have a star that close to your planet. I would imagine that it would be really neat.
Imagine what it would be like on Mercury.
Yeah.
It would be a really hot hopping place.
Okay, next question. We have, here's a great question. What effect does a CME, or a coronal mass ejection, have on Venus's atmosphere, and what happens... Troy didn't spell her. And what happens at solar maximum?
As was mentioned earlier, Venus does not have a magnetic field like we have here on Earth. And when a coronal mass ejection interacts with a planet, it will interact with its magnetic field. And that way, the charged particles and the magnetic field get deflected away. And so we're protected here on the surface. But since Venus doesn't have a magnetic field, only the atmosphere will stop it from getting extra radiation from solar flares. And a coronal mass ejection would not be deflected like it is here near the Earth.
So, I guess with the powerful CME going towards Venus, I mean, in our case, it doesn't really matter because We can't support life on Venus. But it's good from a scientific perspective because you get to see how it affects the atmosphere.
Exactly. Well, you also, you do get to see it interact in a way that it's not going to interact here. But it's a pretty interesting place because we have not only the CME, but as Holly mentioned, the flare. And the flare is light, mostly. It does produce sometimes energetic particles, but it's basically light. So that is stopped by the atmosphere, but it interacts with the atmosphere. And one of the important things that we want to study here on Earth is how energy from the sun, including what's produced by flares, interacts with our atmosphere. That's important for long-term studies of things like climate. And so looking at another planet, one that has an extremely thick and somewhat different atmosphere, gives us a chance to study other aspects of climate and how flares and solar energy affects atmospheres when it impacts it.
Well, speaking of solar flares, you actually had a chance, SGO had a chance to see a solar flare happen before Venus actually crossed the disk of the sun. Tell us about that.
Yeah, well, I almost cried because it wasn't during the transit itself, but it was right before Venus hit the limb for the first time, and there was a filament eruption and a flare that you can see if you look at the data before the actual transit. So that's pretty good. I'll settle for that if we don't get one that's happening during the transit. It's still very exciting, but yeah.
Yeah, and I'll add actually that our friends at Helioviewer make their data available, and it's actually one of their amateur observers, one of their many fans actually made this video that we saw, and then we were able to share it on the Sun Today and share it on some of our other social media sites like Sun Earth Day. So we were surprised. We knew the flare happened, but then thanks to non-scientists who were using our data, we were able to see and be informed about what was going on.
That's pretty cool. Earlier in the program, a question was asked, will we ever see a Mercury and a Venus transit occur at the same time? And of course, we didn't know that figures, but of course, Lou, being the brainiac calculator machine that he is, he actually came up with that, and the first one would occur in 69,000, and the second one was 224,000 some change. So the question is related to that, is there any scientific advantage of having or seeing two transits occur at the same time, Venus and Mercury?
Well, Holly and I talked about that a little bit earlier, and our first answer was not really.
No, I mean it'd be great. Both of them are very valuable if you observe Mercury transit and Venus transit, but to have them together, it would dim the sun a little tiny more, but scientifically, not to have them together, I don't think it would really provide anything extra.
So in other words, you wouldn't cry during that event?
Actually, I might.
Okay.
I might.
We both might cry. That would be pretty exciting to see both of them at the same time.
Well, one of the things we actually haven't touched on much today is that the question is, can the ISS see the transit? Want to share with us?
Absolutely, yes. We have been posting both Sun Earth Day and the Sun Today have been posting imagery that we've received from the ISS, and it's really spectacular.
And that person who's actually taking pictures on the ISS is astronaut Don Pettit, who is the first person to be on station to actually take pictures of a Venus transit. So what an historical occasion for him to be up on station. He's actually taken the pictures from the cupola. So
that might be the only place that's better than here.
Good point.
I think that's a good point, yeah.
Good point. Okay, next question we have is the shadow of Venus ever cast on Earth?
Venus is so far away. Of course, there is a shadow. Any transit will create a shadow, but we are so far away from Venus that shadow won't actually reach us. So not really, but there is a shadow involved. It just doesn't reach us.
Excuse me, I have to flip the paper here. So, okay, next question we have is Venus the only planet that transits the sun that we can see? Which we've kind of answered that question. Which we have.
Yeah, the answer is Mercury. Yeah, because when you think about it, you have to look at the planets that we can see that are between us and the sun, and there's two other planets.
Now here's a great question. How long does a solar flare last?
Oh, that's a great question. Well, solar flares can generally last on the order of minutes, but they can last for up to hours. So we have kind of different types of solar flares. We have what we call impulsive, which are very short. We have long duration solar flares that are often more associated with coronal mass ejections and filament eruptions that Holly was talking about.
And we have another question from our fans. Is Venus transiting just one edge of the sun or the whole sun?
Well, if you're watching the feed, you'll see it that it hit one limb of the sun, and it will transit across, and then in about an hour and a half, it will actually hit the other side of the sun. So both limbs will be transited. Does that make sense?
Yeah,
it makes sense to us.
Yeah. But here's I guess another question as a follow-on to that. So in that 6-hour time frame that Venus is coming across the sun, how much? I guess another question: how much of that sun is actually rotating? How much? What percentage of the sun is rotating in that 6-hour frame? Can we?
Not a whole lot.
Not a whole lot.
In 6 hours, it just doesn't rotate that much.
Okay.
But I will add that something that's interesting there. One of the things that's important is if you're observing with SDO, you're sitting out sort of in front of the Earth, and so you see this somewhat, basically a line moving across. And if we have these special telescope mounts called equatorial mounts that compensate for the motion of, for example, the Earth, then we see this sort of straight motion across. But if you're looking at it without that telescope mount or with the right glasses, just from standing here, it doesn't have this simple path. And sometimes there's this sort of curved path where it doesn't actually go all the way across, or even curlicue. And if you go to NASA Ed site, you go to Sun Earth Day site, or to SDO and Sun Today, they actually have a little simulation program, and you can see where you are and what you would observe without this special telescope mount.
Oh, that's great. That's awesome. And also another question, just kind of off the top of my head. I just forgot the question.
You're not allowed to ask questions.
I guess I can't ask questions. But anyway, I'll think about that question. We'll get back to you on that. So you're watching NASA Edge live coverage. Thank you, Holly and Alex, for answering some great questions. As you look behind us, the sun is starting to set. We're getting close to the wrap-up of the Venus transit. We still have about an hour and a half left in this broadcast. And we're still been fortunate with great weather out here, sunny skies, clear skies, and really, I don't think we have had any clouds cover the sun today.
Yeah, not up here.
Not at all.
Hey, you're watching NASA Edge, an inside and outside look at all things NASA, and let's go back and check out the Venus transit.
Here with Troy Klein, who has been involved with social media for the transit today. What kind of activity have you seen online, Troy?
It's been absolutely extraordinary. I have never experienced a social media event quite like this. We've had, keeping up with the Ustream chat room with NASA Edge is almost impossible. It's sub-light speed, just thousands of people asking questions and making comments about every step of this webcast.
Every step.
Every step, even the bad steps.
Oh, we didn't have any bad steps. They were all good steps.
They especially loved the singing that went on today. That was fun.
What kind of response did we get to the singing?
Oh, this is a good song. We love the Sun song and Lou Mayo and the harmony and a few bad comments, but we'll just ignore those. People are having just a great time today.
Now, you weren't alone on the social media.
No, I've been working with Linda Young, and she's also with the Sun today. She's Alex Young's new wife. They just got married Friday, and this is their honeymoon, so we've been having a blast.
Outstanding.
She's awesome.
Now, along with social media, you've seen an uptick in the number of fans on what page?
It's unbelievable. Our Sun Earth Day fan page, if you go to, you can actually just go to venustransit.nasa.gov, which takes you to the existing Sun Earth Day page. Most of the people watching now know that. But when you click on those home pages and the home page of that website, you'll see the Twitter, Facebook, and YouTube, and eventually a Flickr link that are there. And we had probably, about a little over 9,000 new fans today that just joined the Sun Earth Day website.
Now that says a lot about the outreach that's going on here.
It does.
And the education from Sherilyn Morrow and everybody that's here working through the universities, Lou Mayo.
That's right.
The educational component of what we're doing. She just got me.
I can pick up where you left off.
The educational component of what we're doing here today is great, and you can tell by the numbers that we're getting.
That's right. And many people are going straight to all of the education activities and resources that exist on the Sun Earth Day website. And you can find out how to do the parallax activity, for instance, that Lou Mayo and several scientists talked about today. And it gives you step-by-step instructions on how to do it at a middle school level. And it's very, very easy to follow. So what we'd like for people to do is simply go to our Venus Transit Observing Challenge Flickr site, and you can get to that easily. You can follow us on Facebook and Twitter, and you'll find that, or just type that in to the Flickr account. And there are several images of the transit of Venus there that people from all over the world have been posting all day long. And you can download 2 images from different locations on the planet, and then you can also perform your own Venus Transit parallax activity.
What kind of pictures have been uploaded today?
That just has blown me away. I mean, these people are creative in how they're doing their pictures. One of them was the Venus Transit, which is, of course, the picture of the goddess Venus on the side of a subway transiting through town. So that we kind of got a kick out of that.
What city was that?
I don't know. It looked a little bit like Chicago, but I'm not sure. I'll have to go back and check it out. But the other pictures have been people taking pictures of the transit with some cloud cover in the side, and they're just beautiful. It's towards sunset, where many of these people have uploaded these pictures. So we just found out that the beautiful transit picture of Venus on the side of the subway is in Atlanta. So a big shout out to our fans in Atlanta.
And when I came in to get you to come back out here, I was looking at the feed, and I saw there was actually a shot from Columbia, Maryland. It had some trees in the foreground. And I'm originally from Baltimore, Maryland. I now live in Hampton, Virginia, and work out of NASA Langley. But it was so cool that my friends and family back home were able to see if they were at one of the observation sites in Maryland.
That's right. And what's really great about having this Flickr account up is that even though the transit will pass in just less than an hour and a half or so from now, people who have taken pictures all day with their telescopes and pictures of events, please go to that Flickr site, upload them, because NASA also is having a video challenge that we're advertising, to where we're asking people to go online and be part of this challenge through the Science Mission Directorate, and it's being advertised on our Facebook site and through NASA. And they're basically asking the public to go out, look at the videos that everybody has been capturing today, that you've been seeing today, that are on the air, and then make your own video mashup. And then share that with us, and we have a challenge and a competition for that.
You said the word mashup. It reminds me of, no, I shouldn't say it like that. My wife is moved here from London in '89, and she uses the word mashup a lot. I'd like to say hello to Sharon, my son TJ, and my 11-month-old twins, Christian and Cameron.
That's awesome.
Yes.
That's awesome.
Yeah, I hope you're watching.
You know what else has been really nice? We also, many of the NASA missions, the new NASA missions that are going up, including the current ones like SDO, of course, which we've been hearing about all day with their amazing images. With the Helio viewer, have you seen the pictures from the Helio viewer?
Absolutely. We've actually been putting up different shots from SDO all day long.
They are just beautiful with the different filters of light. And what's really awesome about this is when the shuttles were retired, many people have been asking many of us questions, thinking that, oh, maybe NASA is, disappearing. And we know that that flat out isn't true, that we're actually very busy.
Yes.
And we have many launches for satellites and different things coming up, including missions like the upcoming magnetospheric multi-scale mission, which is the other mission that I work for, which is I'm one of the education and public outreach people for that mission.
Now, we've been up to Goddard covering MMS for quite a while now.
That's right.
Can you tell the viewers a little bit about what that mission is all about?
Yeah, MMS is being built and constructed to study the trigger of space weather, the beginning of space weather, which are magnetic reconnection events. And actually, one of the best ways to get, I'm the education and public outreach and I specialist, and I do education technology and social media. And so what I do is I connect everybody I can to the scientists who have all of the facts, and the engineers, and the mathematicians, and the technologists. So we have the entire suite of careers, and not only that, MMS is comprised of people who are administrative personnel, who also help us with our graphic design and all the videos that you see. We have just an amazing number of careers that are involved in just one mission. So when you go to the MMS website, which is mms.gsfc.nasa.gov, you can join our Facebook and Twitter accounts, and you can follow what we're doing as the mission is actually being built and constructed at Goddard Space Flight Center right now. And what's really awesome, it's not just one satellite, it's four.
Absolutely.
Right. And they will fly in concert around the Earth for 2 years studying magnetic reconnection.
We've been in the clean rooms while they were putting on the jets on some of the components, and we were sitting there talking to the engineers about, pretty much covering this mission every step of the way. So you'll definitely see more from NASA Edge and MMS over the upcoming months and years.
That's right. You guys have done 2 complete vodcasts for us, with more on the way. And I understand that the mission vodcast that you did for a while were your #1 download?
Yes.
That's
you know
awesome.
what? You know what? Just like you said before, the shuttles have been retired, but there are a lot of NASA enthusiasts out there that know that we still have a lot in the tank, and basically we're just getting started.
That's right. And we're inviting kids from around the world, and adults and anybody, to join us in learning how a mission is actually put together. And right now, because we're still a little ways out from the mission launching, right now is the time for schools and people around the world to jump in, to the action and join us. We have a new transmedia book coming out, which is a whole new concept, and it actually lets students do digital fabrication and 3D fabrication in their classrooms and create models of the MMS spacecraft and do experiments with magnetism and the launch sequence of the mission. It's just an amazing resource. And we also have a new math guide that's coming out very soon, and we'll be posting that on the MMS website. So we're really focusing on engineering and science right now.
How awesome is that?
It's amazing.
That is amazing.
We're excited.
And back here to the Venus Transit, Ron, what view do we have now? We're up, Yeah, we've just been hanging with us.
I know. I should put my glasses on.
We were on Calcium K, the view. Troy is taking a look at the sun. I'm not, because I don't have the proper eyewear. We're now looking at Calcium K.
Take a quick look. It's amazing to look through these solar glasses because you get that connection to the universe.
And you can absolutely see it.
You can. If people wondered if you could see something they thought would be so small, but it's clear.
And as we've gone through the day, I checked them out. We were pretty good to go. We've gone through the day. We've been telling everybody to make sure that they engage in safe viewing.
That's right.
We have glasses here. We have the proper eyewear. You have to make sure when you're taking pictures with your cameras that you have the right solar filters on so that you don't ruin your eyes and the sensors on your camera. But we definitely don't want you to ruin your eyes by looking directly into the sun.
No, we want to enjoy the entire transit with no problems.
Now we're on the H Alpha view. Troy, it's been a pleasure to have you on here. We might have you come out toward the egress.
Sure. We'll give you some final numbers on people who've been joining the website.
Absolutely. Just run down your websites again, because right now, if you are online and you're viewing us right now, you have to check out these NASA websites. Become fans of the page so you can get updates when Troy and the different missions that he's working with put out updates so you can stay abreast of what's going on at NASA.
Well, the easiest place to go to begin with is venustransit.nasa.gov. And when you're there, you'll find links to other various websites. We've also been working closely, as you know, with the Sun Today, with Alex Young, and that's an amazing website. And we're working our programs together as much as we can.
Alex, I think, might be the most excited scientists out here today.
It's so fun to work with people like that. It's just incredible. And of course, Cheryl Moore.
Yes, off camera, doing jumping jacks with a sun shirt on.
And then, of course, as many of you know now, go to the SDO website. And I don't want you to forget this. We're getting images, when we have been for a little while now, from the International Space Station.
Yes. Talk about that.
And, well, they're beautiful. And we have Don Pettit who has been sending images down to a Flickr group. And you can go to the Facebook page and to their Flickr account for the International Space Station, and you'll be able to see those images right now. And it's just phenomenal. We might actually, if we don't already, have a video from ISS of the transit of Venus. And that's what I'm hoping for.
Hey, Ron, do we have that? We don't? Okay. We're efforting some images from the ISS as we speak. But Troy, as we go back to our views of the final moments of the Venus transit, I'd like to thank you for coming on, and we'll look for those numbers later on.
That's
in
right.
the evening.
And you have questions about the mission we work for, just go to NASA Edge, watch those videos and those podcasts. You'll learn everything you need to know right now.
At the NASA, on the NASA portal and at iTunes. Go ahead and download them, all of them. Thank you. Thanks, Troy.
E o mai kai ke mai luna mai e. O na mea huna noi au. O na mele. E o mai. E o mai. E o mai.
3, 2, 1, 0. Booster ignition and liftoff of Discovery. When you think of space exploration, most people think of NASA, the National Aeronautics and Space Administration. When you think of telescopes, observatories like Palomar might come to mind. And what about astronomers? You might think immediately of Galileo or Sir Isaac Newton. But what if we mentioned King David Kalakaua, or Mauna Kea, the tallest mountain on Earth, or the Venus Transit? What do these subjects have in common? The answer is Hawaii's preferred place, connecting our Earth to the stars. It is a tiny island dot within Earth's largest ocean, and it is a metaphor for Earth's place in the cosmos. Sitting upon the highest mountain on Earth, as seen from the depths of the Pacific Ocean, Hawaii holds a special place, connecting Earth to the cosmos. First came the Polynesians, who trusted their navigational instincts to the nighttime stars above. They had names for their star guides. Kamaka, the point of the fishhook in the constellation Scorpius. Makalai, the little eyes within the Pleiades. Hoku'ula, the red star in the constellation Taurus. After the Polynesians came the Europeans in 1778 under the command of Captain James Cook, who earlier had been the commander of the British Venus Transit expedition to the Polynesian island of Tahiti in 1769. Cook determined Hawaii's longitude and latitude and appointed Hawaii a place on the cartographer's map. He brought with him spyglasses, clocks, sextants, charts, foreign ideas, and techniques that astounded the intelligent native population. But the new European ideas soon crowded out the old Polynesian ways of looking at the skies, and much of the ancient knowledge was forgotten. For a time. A new awareness of the cosmos was reborn under the scientific patronage of His Highness King David Kalakaua, the Astronomer King.
King David, or Kavika is David, Kalakaua, was our last reigning king. Kalakaua was known for many things. He was the first king to travel around the world in 1881. He was the first visitor to look out of the Lick Observatory in 1882. He also had an interest in science and technology, and he wanted to be able to leave that on to his people. So he actually invited 7 astronomy people from the Royal Observatory in Europe to come here to Hawaii, okay, to view the Venus Transit.
He also opened it up to his people to come and see these telescopes and to interact with astronomers, and I believe from what was shared with me, many people were interested at that time and lined the perimeter of this area that was reserved just so that they could come and observe through these telescopes.
Hawaiians supported the British Royal Society's efforts at recording the Venus Transit in 1874. The mission of the British expedition was to observe a rare transit of Venus across the Sun for the purpose of better determining the value of the astronomical unit, that is, the Earth-Sun distance, and from it, the absolute scale of the solar system. Although Copernicus had, by the 16th century, put the known planets in their correct order, their absolute distances remained unknown. astronomers still needed a celestial yardstick of astronomical units with which to measure distances among the planets and to link the planets to the stars beyond. The British expedition extended over a period of 6 months, from September 1874 to March 1875. The expedition attracted widespread attention from all ranks of island society.
Those astronomers came here from Europe because there were 5 places that were some of the best spots in the world to view the transit from, the Venus transit. And Hawaii was one of those spots. And Kalakaua knew this. So he invited those 7 astronomers to come here. They set up telescopes on 3 different islands. This island is one of them. Oahu, they had their main station. On Kauai and Waimea Town, they had an auxiliary station. And here at Hulihe'e Palace in Kailua Kona, they had an auxiliary station.
Everyone in Hawaii was excited about the transit event. Too much so, in fact. Enthusiastic Hawaiians swarmed onto the campsites, asking to observe the stars through the telescopes. To the serious British scientists, the natives became pests. But to the native Hawaiians, it was their love affair for the stars that propelled their interest in the telescopes. The jocular Hawaiian king proposed if the astronomers would open their observatory grounds to his public for 1 week, then he, in return, would provide his military band for the scientists' amusement every day while they were there. Ironically, on December 8th, the big day, the king was absent, being in Washington to promote Hawaiian interests in a new trade agreement with the United States. Since those times, Hawaii continues its love affair for the stars. Everywhere there are reminders of Hawaii's place in the cosmos. There is the Kona Galaxy Garden. Here, different plants depict stars, globular clusters, even nebulae. Many bright stars visible in Earth's night sky are depicted on leaves surrounding the marked location of the sun. Even a fountain has been built to represent the central black hole of our galaxy's center. On Mauna Kea, the tallest mountain in the Pacific Ocean is the Mauna Kea Observatory. The observatory is one of the world's largest, most important land-based astronomy sites in the world. The location is ideal because of its dark skies, good astronomical seeing, clean air, good weather, low humidity, position above most of the water vapor in the atmosphere, and almost equatorial location. Along with the observatories, the Earth of Mauna Kea itself has always held a special significance between the Hawaiian people and the cosmos. On Mauna Kea, there is an ancient quarry from which the material for stone adzes were mined. The adze is a tool used for smoothing rough-cut wood into a relatively smooth surface. Adzes are most often used for squaring up logs or for hollowing out timber into something useful, like a canoe. Since the stone adze is the tool by which canoes were made, and since the canoe was navigated by the night stars, the mineral qualities of Mauna Kea are considered sacred. Indeed, atop Mauna Kea, ancient shrines have been found there. Another reminder of Hawaii's place in the cosmos is the Imiloa Astronomy Center, a place where astronomy meets Hawaiian culture. The Bishop Museum is the largest museum in the Hawaiian Islands. It is the premier natural and cultural history institution in the Pacific. It houses the largest array of Hawaiian artifacts, many which represent Hawaii's special place in the cosmos. There is the Polynesian Voyaging Society, whose members voyage throughout Polynesia, navigating without modern instruments. The society builds replicas of ancient Polynesian seacraft and teaches people about the ancient art of star navigation and wayfinding. But one marker, and the one most significant of Hawaii's place in the cosmos, is the island herself. Hawaii is the largest island closest to the equator. Serenely and quietly, Hawaii sits in a vast ocean with uninterrupted sight of the night sky. In a majestic way, the night sky is awash with stars from the northern hemisphere and most of the stars from the southern hemisphere. Together, the night sky hemispheres over the islands proclaim Hawaii as a special connecting place to the cosmos.
Well, I think for peoples around the world, the stars have guided their lives. And so in particular for the Hawaiian people, it was their familiarity and use of the stars that guided them here from other islands throughout the Pacific, used in navigation. It also set up basically their systems of living. By the movement of the stars and by understanding their patterns, our people use that as sort of their calendar to express when was a good time for fishing, when was a good time for planting, when was the time for a peaceful season, when was the time for a warring season. So they were very in tune with the movement of the celestial bodies in order to establish their system of life.
Hey, welcome back to NASA Edge. Here outside the NASA IRTF, or the Infrared Telescope Facility, on the summit of Mauna Kea in Hawaii, bringing live coverage of the Venus Transit 2012. And Andy Lunt has joined us from LuntSolarSystems.com. How you doing, Andy?
Good. Good.
So how are your telescopes performing so far?
I think they performed really well. Given that the short time we had yesterday to get stuff set up, and coming out here today, got them aligned last night, put them on the floor with some tape on the ground, and I think they've been tracking pretty well all day.
I tell you what, no, it's been a great event so far, and we have just over an hour until third contact of the transit. So it'd be the last two, third and fourth contact, would be the last two contacts, and then that's it. Venus will just kind of just leave the sun.
Really?
Right?
Yes.
Okay. Okay. Well,
until next time.
Well,
I'm glad we got this one right.
Will you join us in 2117?
I'll be here for sure.
Okay. Very good.
Absolutely.
Well, we do have some questions regarding telescopes because without telescopes we couldn't watch this event. We could see it through special glasses. But we do have some questions, and some of them are kind of vague, and some are more direct. So let's get to some of these questions, Andy, and just if you have trouble, that's okay.
Okay.
Even though you're a solar guru,
if I have trouble, it's okay.
That's fine. Okay. First question is, can I look at the sun using binoculars if I'm using solar glasses?
Not if you're wearing the solar glasses and you have the binoculars in front of your face, and the binoculars are not covered on the front. No. The solar film that's used in standard solar glasses is a plastic, and it's not designed to take that kind of a heat load that the binoculars would be able to provide to it. If you have a film in front, then you're probably okay. I still have a hard time recommending that anytime either, but definitely not on the eyepiece side of the binocular.
That's a good point, and so a lot of the folks here today have been using glasses without the binoculars, and then also number 14 welding glasses seems to be okay. Yeah,
the density, the neutral density of the glass is designed to take the sun at basically unmagnified intensity.
Now you're a master optician. How difficult is it to actually construct some of these telescopes that you make back at your shop?
Well, the standard telescope that we manufacture, of course, is the hydrogen alpha telescope. And back at our factory, we buy in the raw materials in Tucson. We grind those materials, we polish those materials. It takes about 24 to 48 hours per side, and then they're kind of roughed out. After that, it can take anywhere from 2 to 3 days to actually figure what's going to end up being the high reflector or the resonant surface for the etalon itself. It all depends. The laps are constantly moving one way or another. Polishing is one of those things. If the more you watch the laps go around and around, the longer it seems to take. Sometimes glass finishes really quick, and sometimes it can take a long time. What we do in Tucson, of course, is all our polishing runs 24 hours a day, 7 days a week, 356 days a year. And
56 or 65?
65.
Oh,
yeah,
okay,
thank you. Yeah, I was trying to add up on my fingers, and I ran out of fingers. So, you know, in the beginning, you can imagine there was some very long nights when you go in, you have to check, and glass doesn't finish from 9 to 5. I've found that glass normally finishes from midnight to like 9 o'clock.
Oh,
so,
wow, okay.
Yeah.
Now, is getting a good piece of glass an important first step?
It is the most critical step. And I mean, the heart of the system itself. We have many filters that go into these telescopes, but the heart of the system itself is that etalon. Without that etalon, you would not be able to achieve the 0.5 or the 0.7 angstrom bandpass, and without that, you would not be able to see these active regions on the surface of the sun. Essentially, once you get to about 1 angstrom or wider, you're going to be looking at a sun that would just basically be an orange ball with some little black dots on it, which are effectively would be sunspots.
Now, you're talking about refractors. We had another question saying that is a refractor telescope the best telescope to use when viewing the sun?
The best telescope to use is when looking at narrow band passes is a short focal length refractor. That's typically what we design all our telescopes around. Is essentially an f6 to f7 refractor. I mean, even if the telescope is 1 inch in diameter or 9 inches in diameter, we kind of stick with that model. Okay. The mirror systems have a tendency, you know, of course, they work very well with the mylar in the front for looking at white light. Right. But once you start getting into the narrow bandpass systems, you need to be able to extend focal lengths. You need to be able to you have to deal with heat inside the telescope, which means that, you know, IR filters on the very front anyway. Right. And because you don't want to get your mirrors hot, and you definitely don't want to break that secondary when you put all the heat on the secondary.
Now, another question. This is more of a generic question, and I know that this is going to be easy to answer. I mean, how do telescope filters work, and why do we need them?
Okay. Well, looking at this, when we're viewing solar, of course, we're viewing the full spectrum of light that's available to us, and of course, if you're looking at white light, you're looking at sunspot regions, but the filters come in important at that point. Filters are important at that point because we need to be able to get rid of the infrared, and we need to be able to get rid of the harmful UV. So even though we say, well, we'd like to look at the broadband of the solar spectrum, we still need to get rid of those things that are dangerous to the human eye, right, or would damage an imaging device if they were on the back. So how do filters work? They essentially remove the light that we don't want it to go through the system, right, and only allow that light to go through the system that we're interested in. It's not always possible to do everything that we do there with one filter. In fact, our hydrogen alpha telescopes have 17 filters in them.
17 filters?
17 filters.
So 17 pieces of glass.
17. Well, there's less pieces of glass, but some pieces of glass have one coating on one filter coating on one side, one filter coating on another side. More than half of those are for safety. I mean, of course, we're putting out these telescopes to the general public, and we want to make sure that, you know, safety is our #1 concern. Right. We've been doing this now we've been doing it for about 4 years, and so far our safety record has been impeccable. So, you know, we do the safety. If we could remove all the safety, it would make our life a lot easier. But by putting those safety filters in, it does make our life a little bit more complicated. When you get into some of the other filters, the etalon actually produces multiple center wavelengths of light in a cone kind of shape, and then we have filters that kind of trim out all the bad cones, and then we have one, and we trim that back even more. So it's a process to be able to get all the way through, removing all the reflections and get it really where you need it.
So if I wanted to get one of your hydrogen alpha telescopes from start to finish, how long would it take you to actually make that telescope?
Well, demand is really quite high, and it has been quite high since we started. Essentially, right now, all our telescopes run on about a 3-month backlog. Okay. Now, that's not bad, because when I announced that that Lunt was going to start building solar telescopes almost 5 years ago, at that point we had about 1 year deliveries. Okay. And so we're trying to shorten the deliveries down. We're actually increasing our production all the time. We're growing, and you know, when the sun is as active as it's being, and there's as much great stuff going on, it keeps me really busy, and you know, we're certainly grateful for it.
Now, does it matter in terms of the size of the telescope when viewing the sun?
don't let these little guys fool you. These are small refractors by most astronomy standards for nighttime viewing, but the sun is by far the brightest thing in the sky. Even these refractors at 3 inches, 4 inches, and 5 inches, we're only using a very, very small percentage of the actual light that the telescope is collecting.
Okay.
The larger the aperture, the higher the resolution that you can achieve, but then of course you have to have really pristine seeing conditions, otherwise the column of light, the column of air that you're looking through starts to ripple and really affects them badly. So depending on where you are, what your seeing conditions are, really depends on what size refractor you should be looking at.
So if you were to build a 1 meter solar telescope, what could you see in terms of the features on the sun? How close?
Well, for a long time people thought that 100 millimeters was as big as you should get. And then, so we produced 150 millimeter. I'm kind of like that. So once the 150 started working really well, we decided to go to 230 millimeter. And what we've kind of proven over the last year and a half is that by even producing these large aperture telescopes, we're now, instead of looking at detail on the surface of the sun, we can actually look into detail. We can magnify the sun's image to a point where instead of looking at spicules on the edge of the sun, we can actually split spicules on the edge of the sun. That can only be done with the larger apertures, but again, it has to be done under ideal seeing conditions.
Now, of course, we're seeing the transit. It's going to be ending here in a little over an hour, and we're going to be waiting, another 105 years for the next transit. Where do you see the technology in solar telescopes 5, 10, 15 years down the road?
Oh boy, at the rate that solar technology has taken off over the last, if you think about it, this only became part of common viewing about 12 years ago, 14 years ago. And when hydrogen alpha telescopes started coming out into the general public, nobody knew anything about them because only NASA and the large facilities had these enormously expensive filter systems.
Right.
So we have to develop the technologies, and so we're really truly in our infancy about what we can do. And of course, we're still learning. We have these interactions with you guys, and I'm so grateful to be here and learn about these cameras and all this kind of stuff because it certainly gives me really good food for thought when I go back to the shop
That's
now.
right.
And I'm going to be, I'm already stewing in my head about all these great things I could be doing, how I could make events like this better next time,
right,
and how we can go away with this with a really good learning experience.
And I like to talk about all the events that you do. You travel quite a bit, each year. And so, what's the reaction like? You go to events and you always run into people that have your telescopes, and some of the events you're seeing hundreds of people viewing the sun. And tell us a little bit about those events.
We go to events, of course, and I like to look at solar observing as a very social event. Here we are in the sun, and I can actually see what you look like. Nighttime observing, of course, nobody's allowed to have lights on and stuff. But whenever we go anywhere and we set up solar telescopes, people are kind of curious. They have to get over that first mindset of, I'm not supposed to look through the sun. My mom told me I couldn't. Well, if you don't want to listen to your mom, I'm the guy to talk to here. But pretty much once we start getting people lined up looking through, everybody comes to look through, and people are so amazed looking through the eyepiece. It's something that's happening in real time. It's very large, it's very bright, and it's very active. And so once you start, and especially when there's a little flare going off the edge, everybody sees things differently, and they walk away. I try to, give them a little, education while they're sitting at the eyepiece. They walk away, they talk about it, they come back, and they look again. So again, astronomy, nighttime astronomy is has a huge following. Solar is still trying to develop that following, but I think we've got an easier case. I think eventually solar will be as big as nighttime astronomy, simply because we can educate kids, we can educate people during the day.
Okay, I got a question for you, and this is, you may not want to answer this, but we'll have to see. Do you by chance happen to have a secret room like Tony Stark does? You have your own lab. You have your own lab downstairs where you're just sitting there tinkering with the new system, and everyone's upstairs in the shop making telescopes, but you're by yourself like Tony Stark and coming up with something.
No, I don't really have a secret. Most of the design, my wife would tell you, if Andy's laying on the bed staring at the spinning fan on the ceiling, do not disturb him. He is. I invent things in my head, and the spinning fan kind of keeps everything out and allows me to focus on what I put telescopes together in my head. And, I often get complaints when I go to work and I tell people, this is what we're going to do, and all of a sudden we have a new product, and everybody goes, well, where did that come from? I said, well, I just thought it up, so.
It came from looking at a fan.
Yeah, and so, a lot of these, sort of the pressure tune system by recreating the atmosphere anywhere on the Earth inside the optical chamber of a telescope was unique, and I had been told by many people it couldn't be done. And so, I trotted off and put a few things together, and here we are. And now pressure-tuned Lunt solar scopes are by far the hottest seller of any.
And a double pump.
Yeah, we have the doubles too. The gentleman over here has to have a double pump. And I'm always amazed too when I go places that, I'll be standing, go out to Page, Arizona, in the middle of nowhere, and I look around the visitor center, and there's 3 of my telescopes. I happen to be going up on top of Mount Lemmon in Arizona, and the first telescope that all the visitors get to look through when they go up there was one of my telescopes.
That's awesome.
So I'm just kind of like, thrilled that I have this opportunity to provide these kind of instrumentation to people, and we're just hoping to advance this hobby, and this is the way to do it.
Well, Andy, we really appreciate it. I can't thank you enough again for allowing us to use 3 of your telescopes. It's just, they're phenomenal scopes. The images that we're getting from them are phenomenal. I think it's, for us, NASA Edge, it's a breakthrough because we're taking those red cameras and hooking them up to your telescopes, something we didn't even dream of a couple of years ago until we realized that we were actually going to be broadcasting here from Mauna Kea, and just coming up with the idea that how can we mount a telescope to a red? It's come a long way.
I mean, it was like, what was it, about 6 months ago, my secretary comes in my office and says, NASA's calling, and I'm like, it's about time.
That's right. Yeah. So, but once again, Andy Lunt from luntsolarsystems.com, thank you so much again for letting us use your scopes, and we're going to go back and see the sun, the Venus transit, with Lunt telescopes.
Excellent.
You're watching NASA Edge, an inside and outside look at all things NASA.
Welcome back to continuing live coverage of the Transit of Venus 2012. We're here, still here atop Mauna Kea, but we're still getting questions about Venus, the transit, and other planetary issues. So I thought I would start with some questions for Kelly Fast and Sherilyn Morrow, but you guys can decide who wants to field these questions. One of the first questions I have is, and I thought this was very interesting, were indigenous Mesoamerican astronomers aware of the transit of Venus?
Well, from what I've seen, I guess they're actually, I guess the ancient Assyrians, there's maybe a tentative reference to that effect, but apparently around Montezuma's time there might have also been some sort of tentative reference. So I guess it's nothing that's confirmed, but there is a possibility that at least in Montezuma's era in Mesoamerica, yes, that could have happened.
And certainly the Mayans were some of the most incredible observers, ancient observers of Venus. Their calendar is so precise, even by modern standards. And it's interesting, that the Venus transit marks the end of their latest calendar.
Yeah.
Wow, they have temples and signs for Venus. Venus was even more important than the sun to them.
Wow.
The Mayans were really exceptional Venus observers.
Well, it's interesting, too, because we talked to Gary Fujihara early and Koa Rice, and they were talking about all the rich history of astronomy that's taken place here among the Hawaiian people as well. So, I kind of feel like, and I'm freelancing here because I have no expertise, but it seems like one thing that we do know, as you said, is that there was lots of observation going on for centuries and centuries and centuries. So whether they identified it as such maybe is the question, but certainly they may have seen it. Okay, all right, so I had another question, and I thought this was interesting because I know so little about the scientific side of things. I'm learning all the time here, and I thought this was a great question. Are Venus and the Sun rotating in the same direction?
Yeah, my dissertation was about the rotation of the Sun. And so the Sun actually does rotate on average, it's 28, 30 days. It rotates more rapidly near the equator than the poles. So it's rotating in the same sense that most of the planets of the solar system rotate. But Venus, for some mysterious reason that is really not understood, rotates what we call retrograde or backwards relative to the other planets in the solar system. So all of the other planets, well, Uranus is tipped on its side, okay? And so that's a little funky too.
I was going to say it. Venus saying like, why are all the other planets rotating in the wrong direction,
But and again, Venus's day, its rotational period is longer than its orbital period.
Interesting.
Yeah.
Okay, so they are just now my question, or the first thought I had when I even heard this question was, well, if they do rotate in different directions, what kind of impact does that have on Venus as a planet and maybe its role in the solar system?
Well, it's an interesting, you said impact. I mean, why does Venus do this? Because, of course, the nebula out of gas and dust, out of which the whole solar system formed, gave us a sense of which way things ought to be rotating, but probably some form of an impact in the early solar system created this. And of course, yes, that slow rotation does change the atmospheric dynamics a lot. You heard earlier in the show that there's a level of the atmosphere of Venus that super rotates 60 times faster than the surface of Venus.
Wow.
Right, so it's incredible, and that's a mystery. Dynamicists do not understand why that is yet.
So what you're saying is if they were broadcasting on Venus right now, and they heard us complaining about the winds here, they would laugh and mock us and say we're windy. Okay. All right. Well, that's very interesting. Okay, another question. Just want to run through a few of these. We don't want to neglect our audience members. This is from Tom and Heidi from Space is What's Next. They asked when the next Mercury transit would be, and then they followed up with what I thought was a very interesting question. They said, since Mercury is so small, would we even get a lot of information or the same kind of information we might get during a Venus transit?
Well, the question came in ahead of this, which was great because we were able to look up the date because we weren't carrying that around in our heads. We were so focused on the Venus transit. But it turns out the next Mercury transit will be May 9th, 2016. So not all that far away, but it will be very small. I mean, those of you who have the protective glasses and have been stepping outside and looking up at the sun, and you're able to see Venus, that won't be the case for Mercury. You may need a telescope with a filter to be able to see Mercury. And in terms of what can be done, you can't do the science that you can do with Venus and measuring the distance from the Earth to the Sun using Mercury. It's too close to the Sun to get those parallax shifts from looking from different parts on the Earth.
So glad you said parallax, because I learned about that today.
Oh, tell us what you know, Blair.
I was happy because I learned about it, and then I thought, when you said that it might be too close, it made sense that you...
Well, I have to give credit to Mike Connolly here at the IRTF because we were chatting about it, and he was like, oh, that's going to be way too close. So
Venus
give him credit.
is closer to us than to the Sun, whereas Mercury is closer to the Sun than to us. So there, on average, there's about 10 transits of Mercury, a century.
Okay, but that's another facet of the transit of Venus that actually is beneficial for us, because that's a unique benefit of
the right
transit.
distance, yeah.
So that ended up, I mean, maybe we're not using it now to measure distances, but we got it because of that. And that's
and Mercury doesn't. It has a very. I say it doesn't have an atmosphere. It has an exosphere. There are you've got species hanging around close to Mercury, and there's a mission right now, Messenger, that's studying that. But you wouldn't be able to do the same sort of investigations that are being done with Venus, which is with its thicker atmosphere. It's a totally different game.
It's just funny how the characteristics of a planet and then an event like a transit actually come together to make up a kind of a perfect storm scenario of information for us as observers.
Blair, we were just talking about that. The perfect coincidence that the angular size of the moon matches the angular size of the sun. That is not.
So we got that gorgeous eclipse recently.
And that the Venus transit conspires the orbital geometry and everything, so that it's a day's event. Yeah. It's 6 hours. We can enjoy this and do a webcast of this nature and celebrate Venus like this. It's really wonderful.
Well, with all due respect, I'm going to really celebrate after fourth contact.
You have, Dan. Oh my goodness. We get to go in and warm up, and he has to stay out here.
But really, seriously, it is good that we're all here and witnessing, and all our viewers are getting to share this unique event. Now, the one final question, I don't really know how to answer this. I have my thoughts on this. We have a lot of viewers that are now tuning in the early morning in the UK, and they said because it will be morning in the UK after the fourth contact, will I be able to see Venus continuing its path? I see now that they say after fourth contact. I don't know what the time is.
Yeah, you won't see it right away, but
just earlier in the show we spoke about how every time the Venus catches up on the inside track of Earth's orbit, it disappears from the sky for about 8 days, for about a week. And this is its transition from evening star, which the Hawaiians call Hoku Ahi Ahi.
Oh, wow, that's impressive.
Yeah, and then it doesn't always transit, as we now know, but it does move between Earth and Sun.
Gets lost in the glare of the sun.
Gets lost in the glare of the sun and reappears, about a week later, probably a few days now.
Because you have to wait for it to get far enough away from the sun to continue that motion.
And so it will transition between evening star. It will become a morning star in a few days, perhaps. A morning star which you can see before sunrise in the eastern sky.
All right, so a little bit of post-Venus transit opportunities for viewing in the low in the sky, right? Is that, make sure I understood that correctly?
Yes. And then it'll continue to get higher and higher in the sky each morning.
Okay, well, I really appreciate that. And for all you viewers out there, if you've enjoyed the transit, just make sure that you visit our website at www.nasa.gov/NASAEdge and watch more of our programs, where we don't always do a show on 100-year unique historical events, but we do lots of things with NASA that we're very excited about. I'm sure you will be too. We're going to go now to more solar coverage as we get close to the third contact, which is the egress, and it's the final our final glimpse of Venus in front of the sun. It's about 12 minutes away, and we want to watch this. I'm getting lots of activity. Chris is showing up here.
I have a question. Just popped up.
Step in further a little.
That's a two penetration. What's more important, okay, to you guys? Was it first contact today, or first contact with the Vulcans?
I am a shameless Trekkie, so that's a tough one. But I have to say, I think this beats the first contact with the Vulcans.
Okay, and for the record,
Me too.
For the record, you two can scratch Venus transit off the bucket list. I think the meeting to contact with the Vulcans might remain. Not sure.
It's in the future, perhaps.
I'm gonna hold on to that. Anyway, you're watching NASA Edge, an inside and outside look at all things NASA when we're not watching Star Trek.
Exactly.
All right.
It is science in its most perfect form. While other great events, like the discovery of a polio vaccine, or the identification of radio, or the engineering marvel of the moon landing, are great scientific achievements, the harmony between pure mathematics and science has never been more perfect than our study of the transit of Venus. To the ancients and moderns, Venus was and is the most beautiful object in Earth's night sky. But Venus is also key to a great mystery which continues to fascinate us through its transit across the sun. Although humankind long knew that Venus was a planet, a wanderer in the night sky, its transit became the key to unlocking one of the secrets of the universe. At its simplest, a transit is the act of passing over, across, or through, a passage from one place to another. In the case of Venus, it is the passage of Venus across the face of the sun. It is similar to an eclipse of the sun by the moon, although Venus appears much smaller because it is much farther away from the Earth. The transits of Venus are one of the rarest of predictable astronomical events. During a 243-year period, only 4 sightings of the transit may be observed before the cycle begins again. The transit of Venus became the key to unlocking the mathematical elegance of the cosmos. Nicholas Copernicus and Johannes Kepler knew that the solar system was large, but how large? In 1619, Kepler figured out that Venus was about 30% closer to the Sun than Earth. Mars was 50% further from the Sun than the Earth. But how far was the absolute distance in human? That question stared astronomers in the face and began one of the greatest scientific quests in human history. In 1639, British astronomer Jeremiah Horrocks was the first to observe a transit of Venus based on corrected calculations of Kepler's tables of planetary orbits. In 1719, English astronomer Edmund Halley proposed that the mathematics of parallax could be used to find the actual distance of Earth to the Sun. Parallax is the observed shift in position of an object when viewed from different positions. Surveyors use parallax or triangulation when they need to determine the distance to a remote object. If surveyors could measure remote distances, then why not astronomers? Halley believed that using parallax could answer the question of the distance of the Earth to the Sun. The average distance of the Earth to the Sun is called 1 astronomical unit. From this unit, we have a common way to measure all distances in the cosmos. Halley believed this technique of parallax would work for Venus because of its larger size and because Venus is closer to Earth than Mercury. His prediction was that the results would have an error of just 1%. But the problem is that the opportunity to collect data from a transit of Venus is incredibly rare. In 1769, astronomers were preparing to determine the parallax of Venus and the value of the astronomical unit with certainty. 150 observations of the transit were recorded, but there was another problem. It was discovered that as the edge of Venus approached the edge of the bright sun, a black drop effect spoiled the exact moment of contact. The 1% error Halley was hoping for was not obtainable. Scientists and the world would have to wait another 105 years for the answer of the ages.
Still, to have seen even a part of the transit of Venus is an event to remember for a lifetime, and we felt more delight than can easily be expressed at even this slight gleam of success.
Welcome back to NASA headquarters in Washington, D.C. What you're looking at is a live web stream from Norway of the Venus Transit, the 2012 Venus Transit, as it nears its completion. Back here live with myself, Al Feinberg, senior producer at NASA Television, my colleague, Dwayne Brown, Office of Communications, and the head of our planetary division at NASA Science, Dr. Jim Green. First, we're going to, before we talk a little bit more about the conclusion that's about to occur, we're going to turn it over to Jason Townsend, our media maven, social media maven, who has some really cool stuff to show us. Jason?
Yeah, hi. Thanks, Al. We're still plugging along here, putting up a lot of new images and things like that. We've got a couple of new ones up right now from the Solar Dynamics Observatory. So we're going to start with a full disk image here. This you can see is the full picture of the sun. In a second here, we're going to see if we have the full picture. Here we go, and we've got a wonderful picture with Venus up in the upper right-hand corner. If you zoom in a little bit on the next shot here, you can see it up close. It's a beauty shot there. This is the Venus transit going on. This is past the halfway point. And then if we go to the next one, you can see it in a slightly different band. You can see there's the sun again and everything, looking really good. And also, if you're following at @astro_pettit on Twitter, he's been doing a lot of photography up on the International Space Station. So here's one of his images that he had. But if you look on Flickr and you follow the JSC photo stream on there, or you track it on @NASA, or you track it on NASA Google+, or you track it on NASA Facebook, we've put up a link to all of the ISS pictures, and there's over 900 of them. Wow. So at this point, from the space station. Remember to continue joining the conversation using the hashtag #VenusTransit, and to follow along on @NASA on Twitter, NASA on Facebook, and Google+. And if you are taking photos out there, make sure that you're doing it safely. But if you are, make sure to upload them to our Flickr gallery. We've got a Flickr group going. If you look on Flickr, you can look for Venus Transit. That's the group to look for, and upload your own photos. We've also heard that we've had over 200,000 continuous simultaneous viewers on our webcast online on nasa.gov and on venustransit.nasa.gov. So it's been incredible. Thank you all for joining us throughout the evening. We're going to keep manning the social media here all the way through the end of the event, and we're going to have some amazing time-lapse videos here at the end with the entire full transit going on. So thank you guys very much for joining us, and continue joining the conversation using that hashtag #VenusTransit.
Jason, thanks.